So if I'm not mistaken, the last thing that we sort of talked about was this reflection here, that if you have the sine of a negative angle, then that would be the opposite of the sine of the original angle. For the cosine, nothing changes because the cosine was the x and the x is still positive. The sine was the y, so this one is why it's a negative. And then the tangent, since it's a combination of sine and cosine, so you need one of each, you need an x and a y. So these were true, and I think that's when I had to stop because I ran out of time. Alright. So based on that, and the very first thing that we sort of figured out is that we figured this one out, right? That's the first thing I started with, I think, that the sine of theta plus 90 is the same as the cosine of an angle. So let's replace theta now with a negative theta. Let's see what that does for us. So that would do this. Are you guys okay with that? Well, then we can make this one look a little prettier by just rewriting this. So the sine of 90 minus theta. And what happens here? The cosine of a negative theta is what? It's up here, guys. What can I replace the cosine of a negative theta with? With the cosine of theta, right? Okay. And this sort of proves this whole fact that sine and cosine are co-functions. And I talked about this a while back, but it basically means that like if you know what the cosine of 30 is, which we should know that, right? Let's do the cosine of 60. That's a little easier to think. If the cosine of 60 is a half, right? 60 would be something that looks like this: 1, 2, square root of 3. And the cosine of this would be 1/2, right? So the cosine of 60 is a half. Well, the reason the cosine of 60 is a half because it's a cofunction of the sine. So if you do 60 minus or 90 minus 60, you get 30, right? What's the sine of 30? Now you're in this angle over here. The sine of 30 would be also a half. Well, that's basically what this thing over here says. This sort of proves the whole cofunction thing. Okay? If you have two angles and they're complementary, then the sine of one will be the cosine of the other, and vice versa. I can do the same thing with this one. So I'm going to replace it with a negative theta. I'm going to replace it with a negative theta. Okay. And you should already, even without doing this, you should sort of know what's going to happen here. If the sine and the cosine are cofunctions, then if I write then the cosine of 90 minus theta, shouldn't that then also be equal to the sine of theta? Like, if you just replace these here, if that's true and they're really cofunctions, then it doesn't matter which way you go, which angle you start with. Do you start with the cosine or the sine? And that's sort of what happens here. So how does this negative disappear? Like, this negative does what? The negative for on the inside brings a negative on the outside, right? But since you already had a negative there, what happens? Two negatives make a? Okay, and then this is the little proof that we can do to show that this cofunction relationship works both ways. Okay? And I'm out of room a little bit, so the third one I'm going to put it over here. So then we can also do this for the tangent. So the tangent of theta plus 90 was equal to a negative cotangent of theta. And I don't expect you to quite have all that memorized. I don't think you need to memorize it. But I didn't want to just throw all this out there and say, hey, this works. So the tangent of a negative theta plus 90. So I'm replacing theta with negative thetas. And then let's see what happens here. Alright, so if the sine and the cosine are cofunctions, right? Cosine, it's a cofunction to sine. How about tangent and cotangent? Tangent and cotangent, the reason it's called cotangent is because they are cofunctions. So again, that means that the relationship that we've seen here and over here with the sine, that should hold here as well. So this is going to simplify to the cotangent of theta. Would you believe that? And it has to do with the fact over here that when you take the tangent of a negative angle, it's the opposite of the tangent of the positive angle. Without going into proving that or showing too much over there, what do we know about the tangent and the cotangent? If the tangent is y over x and the cotangent is x over y, is that true? So these are just flipped, right? Yes? So what that means is that I could write this. I could write for the cotangent, I could write that as, well, that's 1 over the tangent. And if you do that and put that in here, now you have a rule for taking that negative out. So the negative that you had over here for the negative theta, you can bring it out to the front of the tangent. And that means that this negative that we started with over here, I lost my marker, so this negative over here, that negative over there gets to cancel with the negative over there because it comes out. But we should go through the tangent to do that. So, and I sort of ran out of room. So that's sort of where we are. So now let's see, why is all this important and how do we work with this? So, so the reason we have some of these rules is because our calculator doesn't really give me what I want. At least not always. So if anybody has a calculator, could you please figure out, so if the sine of theta is a negative 0.628, what do I need to do to find the angle? So I want to know what theta is. So theta is what? How would you do that? If you know that the sine of 8 is a negative 0.682, then what can you do to find theta? Huh? You've done this before, just not with this awkward decimal. Anybody? What if I told you, didn't we do this on the bell work? No, we didn't. We did it a couple of times ago. What if I told you that the sine of theta was a half? What would you do to find theta?
You put one opposite.
You mean that inverse thing? Like this?
No.
No? Okay.
Negative triangle, you put one.
Oh, okay. Alright. You could do that, and it's a special triangle, so that would work. So that's why. So what about it if it was this? Because 1 over 5 doesn't look like a special triangle at all. What would you use? Inverse, wouldn't you? Okay. So wouldn't I be able to do the inverse sine of a negative 0.682, and then that should give me the angle? How much? Okay. Well, I'm sorry, I don't want that. Because it says here, you can only tell me an angle between 0 and 360. Well, I don't care. You're going to subtract it from 360? Okay. Yeah, I understand. Which is right. Okay, the calculator, and we will deal with this later, okay? The calculator can only give you this answer. The calculator is limited. So what you can do is this. If that's a negative 43, I would just draw a picture. That would put me about right there, right? That's a negative 43? Yes? Okay. Well, if I want a positive angle, I do exactly what John says, which is if this is 360, a full rotation, and you are 43 degrees away from it, then what is the angle? Well, take 360, subtract 43, and so the angle would be 317 degrees. You guys okay with that? Alright, well, there's a problem. There's another angle that should work as well. And you can do all these with the relationships that I've proven over the course of the class and a half we spent on this, but I'd rather not, because I don't have them memorized either. So What else can you do? Which, so think of this still as a triangle. So that's a location, right, with an x and a y. Which one of these represents the sign? The x or the y? Think of from this angle, which one of these represents our sign?
Y.
The y. Wouldn't the sign be y over m? Okay, is this y positive or negative?
Negative.
Where else is your y negative? So, draw the same triangle over here. Your reference angle is still 43. Look, we're back at positive reference angles always. So, how far is this rotation? That's 180. How much are you past 180? So, this particular question has two answers. Okay, and if I ask you this question and I tell you you need to be, I did that wrong, sorry. I need to add 43 here, right? I'm sorry. It has two answers, and if I ask you this question, I would fully expect you to answer, or with two answers here, so 223. So it's 223 degrees is my first answer, and my second answer is 317 degrees. And the calculator will not give you that. Okay, it won't even give you one of these. Now, depending on what the original question is, your calculator may or may give you one. That's correct. So I'll do one more of these. So how do you solve theta here? What do you need to do? I want to know what theta is. How do I find theta? You're given the ratio. You need to find the angle. Inverse tangent of negative 0.682, and that returns as your answer a negative 34.3 degrees. Keep in mind that your angle needs to be between 0 and 360. So is that an answer that's allowed? No? Well, draw a picture. So this one is very much the same in the first one. So now you know that your reference angle is 34.3 degrees this way, in the negative direction. Okay, so what's this point here? I need to find this rotation here. If that's 360, how do I find out how much it is to that location? Right, so it's 360 minus 34.3. So one of my answers is 325.7 degrees. Okay, is that the only spot where my tangent could be negative? Where else would your tangent be negative? So if you struggle with this question, all students take calculus, right? You've heard me say that before, all, so everything's positive here. Students, so only your sine's positive here. Take, that will be for your tangent, only your tangent's positive here. And calculus, that will be for your cosine, only your cosine's positive here. So where else is my tangent negative? In quadrant 2. So this triangle also would exist over here, with this being 34.3 again. Okay, now you are not all the way to 180, so your second angle would be what? 180 minus 34.3 degrees again. Okay, and that would be 145.7 degrees. So my two angles would be 145.7 and 325.7 degrees. Now on this one, I could have done it on the same one. If you're not sure, You can type in the tangent of 145.7 on your calculator and see what it does. And you can type in the tangent of 325.7 and see what it does. Okay? The calculator can find tangents of angles larger than 360, well, they can find the tangent of any angle. Same thing with the sine and the cosine. So you can check to see if this does give you a negative 0.682, and if this one also gives you negative 0.682, which they do. So if you're not sure about this, maybe in the beginning, just to give yourself, a happy feeling about this, hopefully, because hopefully you did it right, check it. Just plug it in. Plug in the tangent of the angle you found, see if it's what it's supposed to be. Okay. We will learn later on why the inverse didn't really work. Okay. Part of that you should already know, because we've talked about inverses in the past, right? Yes? I spent quite a bit of time actually on inverse. What do you know about inverses in terms of what type of function do we need? So, I had pictures like this, for example. Okay, so here's a function, that's a quadratic, right? And then here's another function. One of these has an inverse, one of them does not. That's not a function. Sorry. Let me give you another function. So that's a quadratic. We'll just do a straight line. That's a linear. One of these had an inverse, one of them did not. Does anybody remember which one had an inverse and which one does not? And how can you tell from a picture? The second one has an inverse? How do you know? Right. And so on the picture that would be called the horizontal line test, right? Every horizontal line only has one intersection. Yes? 1x, 1y. The fancy word for this is it's a one-to-one function. 1 to 1. Okay. Does a quadratic is a quadratic 1 to 1? Well then, you remember this is why we said initially it doesn't have an inverse. So what did we do to find an inverse? Like we only looked at one side and then we flipped it, right? Or inverted it. Okay? So that's sort of the same idea with sines, cosines, and tangents. You have a problem with a one-to-one function. That's really what you have.